So we'll know if we get close to 11, we did it right. Alright. So limit as x approaches -2 of x cubed minus x squared minus 5x plus 2 all over x plus 2. Substituting in -2 cubed minus -2 squared minus 5 times -2 plus 2. Oops, yep. All over -2 plus 2. Let's see, that's going to be -8 minus 4 plus 10 plus 2. That's -12. That's 12. We get a 0. -2 plus 2 is 0. Okay, we know we can remove that with factoring. Because this is not a quadratic, we are going to do the synthetic division. So we take the opposite of this, -2. Put in our coefficients, 1, -1, -5, and 2. Raise the first one, nothing goes below, so then -2, adding, -3, multiplying a +6, adding +1, multiplying -2, 0. So our factors are x plus 2, and starting with 1 less power, x squared, minus 3x plus 1. Canceling those out removes the hole in the graph, and we're going to find the limit with the remaining factor. As x approaches -2 of x squared minus 3x plus 1, -2 squared minus 3 times -2 plus 1, that's 4 plus 6 plus 1, oops, 4, 6, and 1 for the 11. Okay, nothing too tricky today. We are going to go back and do one more of the find the delta business, because there's a little challenge in here. So last one. If f of x equals x cubed minus 125 over x minus 5, can you, as you approach 5, can you find the delta if the epsilon equals 0.1? Okay, so we still, and we're going to do everything algebraically. So in order to find delta, you still have to find the limit first. You have to know that. So we got to find the limit as x approaches 5. Limit as x approaches 5 of x cubed minus 125 over x minus 5. 5 cubed minus 125. 5 cubed is 125. I'm going to get the 0 over 0. The indeterminate, which says we can factor and remove the discontinuity. If you want to take a look at the graph, you can. And look at the table. It's not necessary. X cubed minus 125 divided by x minus 5. Let's see, window. The numbers must be too big. Table. Yeah. Let's see. So the y's are bigger. Window x's. Y's maybe negative 30 to 30. See if we get anything. There it is. It's over there. Caught it. looks like this, and as it approaches 5, there's a hole in the graph. So if you want to see what that might be, put it at 5. And it's looking like the y's are jumping over 75. We'll see. We have to do it all algebraically, though. So, because we got the 0 over 0, we have to do the factoring. So we'll do the long division. So that means 5 goes into, you need the 1x cubed. You have to have a placeholder for the x squared, for the x to the first, and then our constant. Raise, multiplying you get 5, adding you get 5, multiplying 25, adding 25, that would be 125, which is good because that gives us 0. So, we've got x minus 5 as a factor, and the other, this starts out, remember, x squared plus 5x plus 25. Remove the discontinuity. Now we can get the limit. Oh, I think I checked. The limit as x approaches 5 of x squared plus 5x plus 25. Substituting in the 5 squared, 5 times 5, plus 25, looks like 3/4 to me, 75. Okay, so now our whole goal was to find delta in this problem. That's your triple inequality, and we're going to go 0.1 away from the 75. So that means we're going to go to 75.1 and 74.9. So there's our triple inequality boundaries. 75.1 is less than, I've got a quadratic equation in the middle. X squared plus 5x plus 25 is less than 70, oh, I put the wrong one, for God's sake. It's the 75 minus the 0.1 here for the 74.9. And the 75 plus the 0.1 over here for the 75.1. Smaller to bigger. Okay, the problem is, we haven't had this, well, we did in chapter 1 a little bit, but I didn't focus on it too much. I just did that one, it was on review day. There's a quadratic equation in the middle here. In order to solve a quadratic equation, you use quadratic formula, and we're going to use the program for that. But the quadratic equation, before you plug in the formula, has to be in standard form. Standard form is equal to 0. So you are going to want to take the time to write this, break this apart into the two separate inequalities. So 74.9 is less than x squared plus 5x plus 25. And then the other one, x squared plus 5x plus 25 is less than 75.1. Again, like I said, to use the quadratic formula, this has to be equal to 0 over here. So we're going to subtract the 74.9. So we've got 0 less than x squared plus 5x, and then there, quit. 25 minus 74.9 is minus 49.9. Back to that. Over here, let's subtract 75.1. X squared plus 5x, and then 25 minus 75.1 minus 50.1. Okay, I'll stay here. So if you don't have the quadratic formula yet, you're going to get it. The program I have is, there's a lot of them out there, A111 quad. A value, remember, is your x squared, so that's 1. B is your x, that's a 5. And C is your constant. Here it's a negative 50.1. So x is less than 5.0067 or negative 10.0067. Well, let's think about it. The delta is the distance away from 5, because that was my x value I was approaching was 5. The negative 10 is way far away. We can just throw that one away. Remember, because we always want the closest delta. So the delta on this one is the distance away from 5. So on this side of the inequality, we got 0.0067 for a delta. Now we got to do the other one. Here, run the program again. 1, 5, negative 49.9, and I'll be back in 1 second. Hello. Yeah, but she said after 2 o'clock. Or, oh, I thought it was 1 o'clock your time. I was waiting till 2. Oh, I saw your email. I looked. You know what it is? They sent the full $2,000 now instead of the $1,000 a semester. So I wrote the check just minus $1,000, so that's all it is. It's your scholarship money that we're basically getting back. So you'll just have to give that to me next semester. So I don't know if you want to do a direct deposit into your checking or savings account or whatever. Unless you want to just... Oh, you're going to pick it up? Okay. Well, then you got to hold on to it until you get home. I don't know if they'll mail it to you at campus or at home. I don't know. Okay. I know. I think you can still do direct deposit, can't you? Go ask them if you can still do direct deposit and fill that paperwork out, maybe. Oh, yeah. All right. Okay. All right, then just ask them to mail it home then or whatever. Or you can mail it home, or... Yeah. And then I'll put it in your account when I get home. Or when it gets here, I mean. Yeah. Okay, yeah, so that's what's happening. They sent all 2,000. Okay. Don't lose the dings. You got envelopes and stamps to mail it home? Okay. All right. Okay, sounds good. Wrap it up in like a letter, you know, like a piece of paper, so you can't just see the check. All right. All right, I think direct deposit's easier, but that's okay. You do your thing. Okay. Okay, see what your options are. All right, sounds good. Okay, bye. Okay, so we got 4.9933 and negative 9.9933. And again, we want the one close to 5. We're going to throw this